Hello, hello. Here we are again. This time on isosceles and equilateral triangles. Okay, so we've talked about these kind of informally all throughout the year, kind of because I think you learned about these kind of triangles a very long time ago. So now we're just going to kind of focus in and really formally talk about these two kinds of triangles. So the first one we're going to talk about is an isosceles triangles. We just have some general vocab to go over here. So remember, an isosceles triangle has two congruent sides, right? And we call these the legs. So this would be a leg, and this would be a leg. Okay? I guess we could write that here too. So AB and BC would be your legs. The angle where your two legs intersect is called the vertex angle. That's right here. Angle B is your vertex angle. Or angle 1, so we'll put that right here. Angle 1 is your vertex angle, or angle B. The side opposite your vertex angle is called your base. And typically when we see an isosceles triangle, this is usually on the bottom, right? So we call it the base, the bottom. That's AC. And then the two angles that are along the base are called the base angles. So that'd be like angle A and angle C. Those are base angles. Yeah, those right there. So angle 2 and angle 3 are your base angles, and they're the same measure. They are congruent. Maybe you want to put little archy marks. So in a nutshell, that's like the anatomy of an isosceles triangle. And from this, we know two things. We have this isosceles triangle theorem. I don't ever call it that, but that's technically what this is. But it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we knew AB was congruent to BC, then we automatically know that those base angles are congruent. Then angle 2 is congruent to angle 3. And then the converse of that is also true. So remember, the converse is when we flip the order of our statement. So if we knew we had two angles that are congruent in a triangle, then the sides opposite those two angles are also congruent. So in our example here, if we knew angle 2 was congruent to angle 3, then we would know AB is congruent to BC. Okay? Super. Good job. Name two unmarked congruent angles. So we're going to use those theorems we just talked about, or those two, they're theorems, that's what they are. So name two unmarked congruent angles. So we're kind of focusing on this triangle over here, right? Do you guys see how, and I'll erase this. We have these tick marks. So we have two congruent sides, so that I know that the angles across from them are equal. So we know angle B is congruent to angle, we gotta trace this one out, ACB. And you guys see how they weren't marked, but we still knew that they're congruent? There's no marking telling me that other than that these two sides are congruent. So that's how we knew, okay? Now we're gonna do the opposite. Can we name two unmarked congruent sides? So let's focus on this other isosceles triangle. Well, there's a congruent angle, there's a congruent angle, so then I know the sides opposite them would be congruent. So we would know that side AD is congruent to side AC. Because they're across from equal angles. Perfect. Nice. Next, a fun little proof. This one's fun, it's cute. There's not a lot to it. I'm going to abbreviate statements and reasons here. So our goal is to show that this guy, DE, is congruent to EF. That's our end goal. How are we going to do that? Well, let's see. We're given that angle 1 is congruent to angle 4. And that's all we're given. So we're going to basically prove what we just, our last theorem. If we have two angles that are congruent, then the sides opposite that are congruent. So if we just write down our given here, angle 1 is congruent to angle 4, given. What else do we know? Well, if we just look at our picture, we're just looking at it. What else is congruent to angle 4 just by our picture? Well, I'm hoping you're thinking angle 2, right? Because they're vertical angles, right? Angle 2. So angle 2 is congruent to angle 4 by vertical angles. And then we haven't seen this property in a while, but we love it. If 1's congruent to angle 4 and 2 is congruent to angle 4, what two angles are not congruent? Angle 1 and angle 2, you're right. Remember what property that is? That's our transitive. Yep, sure is. So now that we've stated that angle 1 and angle 2 are congruent, we know the sides opposite them are congruent. And that's, you guys, what we wanted to say the whole time. So now we're done. We can say segment DE is congruent to segment FE. And I guess if you really wanted, you could say converse of the isosceles triangle theorem. My brain doesn't remember that, so I'm just going to say across from congruent angles, because that is also true. You write whatever your brain likes to write, but that's how my brain understands stuff, so I'm going to write. Okay. This next one is, she's a fun one. She's a fun one. It's a real thinker, okay? So again, we're writing a proof. Okay, so again, we're going to have our statements and our reasons. So let's see here. We're told of quite a few things. So the big triangle ADE is isosceles with vertex angle E. So now, right now, I know angle A is congruent to angle D, and AE is congruent to ED, all because it's isosceles. So I just marked my given, okay? Then we're also told that AB, this little guy, is congruent to CD. Again, not just given to us. And now our end goal is to show that BE and CE are the same. So it's quite a process, right? But we did one of these actually yesterday yesterday in our video lesson. We have to first show that these triangles here on the outside, so triangle AEB, this guy here on the outside, is congruent to this triangle over here. And then since those green segments are in, oh no, shoot, 1 second, you guys. No, well, just kidding. Since those green segments, B, E, and CE are in corresponding spots, they're congruent because we'll show that the triangles are congruent. So let's back it up a second here. Okay, so let's just start from the beginning. All right, so let's start with this isosceles triangle. So we're going to say isosceles triangle ADE. That's given. And then we're told AB is congruent to CD. Given. Okay. So now let's list the other congruencies we wrote down. So we now know that angle A, we mark this as congruent to angle D. We know that because they're across from congruent sides. Yep. Across from congruent sides. And then we also know from our isosceles triangle that AE is congruent to ED. And you honestly, guys, why is that true? Well, definition of an isosceles triangle is two legs congruent, and there they are. So we'll just say definition of isosceles triangle. Okay, so now, folks, hopefully you're with me. Look, we have a side angle side. we have a side, angle, side. So now we know that those two triangles are congruent. So triangle ABE is congruent to triangle DEC by side, angle, side. Now we're almost done. We have one more step left. So if we look here, folks, our end goal was to show that BE is congruent to CE. Oops, I wrote this in the wrong order. This should be DCE. There we go. I didn't go the right way. My brain thought. So now we can look. Either at our picture, we notice that BE and CE are in matching spots, right, you guys? Those are in matching spots. Or if we look at our congruent statement, BE is right there, CE is right there, so they're in matching spots. So if you remember from yesterday, the theorem that says if you have congruent triangles, then corresponding parts are congruent is that CPCTC. Corresponding parts of congruent triangles are congruent. That's a fun one. Isn't it kind of fun? Like the more difficult ones you can do. You guys are so smart. Okay, well now I gotta go through this. All right, and then we'll finish up with some equilateral triangles. There's nothing real fancy about these guys. Are kind of boring almost. What do we know about equilateral triangles? We know that all our angles are the same, and they actually all measure 60 degrees. So that's kind of boring, and all of our sides are the same. That's what we know about an equilateral triangle. So, a few things about an equilateral triangle. It's only an equilateral triangle if and only if measure of angle A is congruent to measure of angle B and the measure of angle C. Then we would know that side AB is congruent to BC, which is congruent to AC. Or we could go the other way. If AB equals BC equals AC, then we would know that the measure of angle A equals the measure of angle B equals the measure of angle C. Okay, and formality, you guys already know that. We already know all of our sides are congruent and all of our angles are the same. And again, they're all 60 degrees. Now we'll finish up with some easy problems here. Find the variable. We can do this. Hopefully you're thinking this is isosceles because they have two base angles the same. So then I would know that these are the same. So 15x plus 7 is congruent to 23x minus 17. Get your x's to one side and your numbers to the other. So we'll have 24 equals 8x. X is equal to 3. Done. Now we're going the opposite way. This time I have two congruent sides, so we know that our base angles are congruent. Set these bad boys equal to each other. Get your variables to one side, your constants to the other, divide out, and hopefully you get a nice whole number of 8. And then lastly, we have this equilateral triangle. So we're finding x and y. It doesn't matter. Should we just go alphabetical? Should we find x first? So x is pointing at angle R. Well, we know all of our angles measure 60 degrees, so we can simply just set that expression to 60, add over 3, divide out, and we should get 9. Find y. It's your choice. All your sides are the same, right? So pick whatever two expressions speak to you. I'm just going to pick these two because, I don't know. I'm just going for it. Minus 23 equals 9y plus 1. Again, get your variables to one side, your numbers to the other. Divide out, and you should get 12. All right, folks, you have a book assignment. It's on the calendar. Finish that up over the weekend, and I will see you Monday. Have a great weekend. Be good. Be safe. Wear your seatbelt. Be united. Onward, Central.